Our methods of variance analysis are comparing what the earned value on the project is with the expected schedule value. So where should we have been at this current date in the project? And also comparing that earned value with our actual costs. We have three data elements when we're looking at our project. We have our planned cost of work, the budgeted cost of the work completed, and the actual cost of the work completed. When we're looking at our schedule and cost variances, we're looking at if we have positive or negative variances. So if we have a negative variance, this means that we've either spent too much money or we're behind on our time to completion. If we have a positive variance, we are both ahead of schedule and we are saving money. Our cost variance shows us if the work completed to date costs more or less than what we planned at any point in the project. So if we're at week 6 and we say that at week 6 we should be 50% complete and have spent 50% of the budget, but instead we are 40% complete, but we've spent 60% of the budget. This would show a cost variance of being over budget and a schedule variance of being behind on time for the progress of the work packages that we had scheduled to be complete. This is an example of our cost schedule graph. So in this example, we have what our project baseline is, what the actual cost is, and what the earned value is. So we can see that as of today, our project baseline was that we would be 85% complete. Our actual cost is 85% of our total cost. So our actual cost is $340, where we should have been for our baseline is just over 50% of our cost. And our earned value right now is at 50%. So we can see here that we're over costs and we're projecting that we're going to go past schedule. So we can see that then we've made the future projection with our EAC, or estimated cost of completion, and we're going to be past our scheduled end date and overrun on our costs. When we look at the different earned value, so we can see variances in these graphs. So in the top left graph, we have both a negative schedule variance and a negative cost variance. So our actual costs are greater than our budgeted costs, and we're overrun on our time. In the second example, in the top right corner, we have a positive schedule variance, but a negative cost variance. So we're ahead of schedule, but we've spent more money than we had budgeted. In the bottom left corner, this graph shows a situation where both of our variances are positive and our projection is going well. And in the bottom left, we have that the schedule variance is negative, so we're going to run over on time, but our cost variance is positive, so we're not going to spend as much money as we had budgeted. When we're creating a status report to update the people that we need to update, we need to make some assumptions. So one of the assumptions is that each cost account has only one work package, and each cost account is represented as a single activity on the network. Another assumption is that our project network early start times are our basis for assigning our baseline values. And from the moment work on an activity begins, some actual costs will be incurred each period until the activity is completed. So this is that assumption that if we have a activity that takes 4 work periods, that 25% of the cost will be allotted equally over the work periods. That's that assumption that we're going to allocate costs over a certain percentage of time. Different measurements that we're going to look at in order to measure our production are on this next slide. There are a number of performance indexes that we can use. The first one is the cost performance index. This is our earned value divided by our actual cost. This index measures the cost efficiency of work accomplished to date and is considered a statistically accurate way to show what the cost performance index will be on a graph. So the textbook talks about how U.S. government studies have shown that the CPI is stable from the 20% completion point, regardless of our contract type. This can show us an early warning sign if our costs are going to go over what our budgeted plans were. The scheduling performance index is the earned value divided by our planned value. This measures our scheduling efficiency to date. It tells us how well on schedule we are, or if we're over or under schedule. Other percent complete indexes show us how much of the work accomplished represents of the total budgeted dollars and actual dollars to date. So we have our percent complete index of budgeted costs. This is our earned value divided by the BAC, which is the total budgeted amount. And we have our percentage complete index, actual costs, which is our earned value divided by our EAC. And then the management reserve index. This is our cost value divided by our management reserve. So this is how much of that reserve has currently been absorbed by cost underruns. This is an important measurement, a popular measurement in our construction industry for looking at whether or not we can afford to spend more on the project or if we've already looked at project overruns. So when we're looking at this interpretation of indexes, if our index result from our calculation is over 1, we're under cost and ahead of schedule. If it equals 1, we're on cost and on schedule. And if it's below 1, we're over cost or greater than 1. We're over cost and behind schedule. This is an example of our indices from periods 1 through 7. So we have our SPI, which is our scheduling performance index over the time period, 1 through 7. The CPI is our cost performance index, and the PCIB is the percent complete index of budgeted costs. So at period 7, we are at 0.8 for our scheduling performance index. This indicates that 80% worth of work has been accomplished for each dollar worth of work scheduled to date. The CPI indicates that 70 cents worth of planned work to date has been completed for each dollar actually spent. And the percent complete shows that 50% of the total budgeted dollars to date have been spent. Any additional earned value amounts show that the rules applied to short duration activities and small cost activities. The 0-100% rule assumes that 100% of budget credit is earned at once and only when the work is completed, or a 50-50 rule, which allows for 50% of the value of the work package budget to be earned when it is started and 50% when it is completed. So these are for short duration activities or small cost activities. The rule is used before the total budgeted value of an activity can be claimed. So we have this percentage complete with weighted monitoring gates. We use subjected estimated percent completion in combination with hard tangible monitoring points. So we collect our data information in addition to just looking at the percentage of work that should be looked at on long duration activities. So when we can break long duration activities into short work packages of no more than 1 or 2 periods, we can spread those values around. So think about if we have an activity worth $500. That activity can be cut into multiple different projects. So the earned amount at each monitoring gate, so if we said part A would take 20% and part B 30% and part C 50%. So regardless of completion, we would say no more than 20% can be earned at the date of part A, no more than an additional 30% at part B, and then up to 100% at part C. This looks at when we're actually paying out also, if we pay out to our contractors based on their percentage of completion of cost.